community. Feel free to use that and ask your questions there. Okay, and with that, let's make 2021 a better year than 2020. Let's hope with all the vaccinations that we have coming up that we can finally meet up in real life again. Let's see if we can make it through. And if not, stay safe until we get that opportunity again. And with that being said, David, the floor is yours, man.
Hello,
Take it
Mike.
away.
Hello, Mike. Just to
Hi.
confirm very quickly, you can hear me. Nice. Thanks very much for that. And by the way, I must comment, I'm very impressed with your pronunciation of my last name. That was very
Oh,
impressive.
thank you.
So that was
Thank you.
that was really good. So no, thanks very much for having me here. So I'm really excited to be speaking on Azure security, and especially in the area that I'm interested in, which is Azure offensive security. So I'm looking forward to it also. So again, thanks very much. So hello
You're welcome.
everyone, and welcome to this session. So my name is David Okeode. So I'm a cloud security consultant. So I work for a company called Palo Alto Networks. I work in the cloud security division, which is called like a speedboat division, just focused on cloud native security, container security, and anything that has to do with public cloud security, so to speak. So those are my social media handles on the screen. I have a bunch of Azure certifications, and I'm also a Microsoft Azure MVP. So enough about that. Let's just get into what the agenda will look like for today. So let's go to the next slide. So here's what I'll try to cover today. So we'll do a quick introduction of the Azure Cloud Platform from the perspective of security. Like, what are the things that we need to know before we even get into the conversation? So this won't be like just talking about everything Azure, just from what you need to know from the perspective of Azure security. Excuse me. We'll look at what vulnerabilities are, what are the different sources of vulnerabilities, and we'll tie that in with how that impacts the Azure platform. We'll look at the cloud native security model. So this is like the main part of what my conversation with you today will be on. So we'll be speaking about the cloud native security model. And what we'll be looking at here is to try to understand what are the different intersections that exist when we talk about security for Azure. Because in some cases, what we'll find out is that people are so pigeonholed and so or maybe they're looking for a silver bullet to solve an issue. They're just so pigeonholed. Okay, we need to look at cloud configuration, or we need to look at application security, and people are just so focused on that. But what we'll be looking at what are the different security models that you need to be looking at and how they intersect with one another. We'll take that further by looking at mapping vulnerabilities from our conversation on what the different sources of vulnerabilities are. I like showing a demo, so it won't be like a David Okeode the demo without showing you how a live exploit scenario of how attackers actually exploit Azure environments if we make those kind of mistakes. And I'll show you a demo of defending and some lessons and key takeaways at the end of that. So that's sort of like the agenda that we'll go through today. So hopefully you learn one or two things about Azure security. And that's always my goal when I do this kind of events or this kind of sessions, is to make sure that you learn one or two things about Azure security. So a quick reveal of why I do this. So just to give you a quick background of why I like taking a different approach when I talk about Azure security. I'm sure many of you know, you can go on YouTube right now, you can go on the Microsoft documentation website, and you find a lot of existing great documents, videos, talks, sessions, right? Events that focus on talking about best practices on how you do your SAST and your DAST and your AppSec and your AppSec, and how you do your continuous validation. So there's a lot of talks that focus on that aspect of things. So what I like to bring to the conversation is understanding the thinking from an attacker's perspective. Right? I heard somebody said something, I can't remember who it is now, but somebody said something that's very important. It said, when developers build applications, you're building the application for users. But in some cases, you also have to consider that an adversary is also a user of your application. So you also have to build the application with an adversary, with an attacker in mind. And of course, that's not easy to do, right? It takes a lot of training, a lot of knowledge, different skill sets to security is a different skill set essentially from development. So in some cases, it's not like always easy, but understanding that whatever you're building, at some point, an attacker may also need to interact with that. So having that at the back of your mind, it's a great part of cloud cybersecurity education, right? And that's the approach that I try to take. So it's also important for us to learn from the failures of others, right? So we've all heard about all kinds of breaches in the public cloud and how people have made mistakes. When we hear those kind of stories, it's important for us to take a step back to see what happened in this case, right? That's currently going on with the recent breach, with the SolarWinds recent breach. To take a step back to see what happened and what lessons can we take from there to ensure that we are prepared for the next time, right? So, okay, quick overview of like the Azure platform. So the Azure platform is actually not just, and this is from a physical perspective. So the Azure platform is not just one cloud. The Azure cloud is actually 4 different clouds, right? We have the Azure public cloud, we have the Azure US government cloud, we have the Azure Germany cloud, we have the Azure China cloud. And these are 4 different cloud environments. So they are separated from a physical perspective. So they have different data centers that are isolated from each other. There's different clouds, but they're also separated from a logical perspective. The API endpoints are different for Azure public cloud versus Azure Germany or Azure China. The API endpoints are different. The management endpoints are different. The portal for Azure, public Azure is portal.azure.com. The one for Azure China is portal.azure.cn. So they have different management interfaces, different API endpoints. And that's also important to know. So in terms of like the physical space, you have like different region numbers that they have for the different cloud environments. So Microsoft has announced 11 new cloud regions in 11 new regions. And there's something in Azure called availability zones, which are distinct data centers within a region. So out of all the more than about 60 regions that Microsoft has at the moment for the Azure cloud, only 16 of them currently support availability zones. So just to be aware of that. There is another Azure cloud that doesn't get as much mention in some cases, which is the Azure Stack, which is where you can actually host your own cloud privately. So it has similar API endpoints. It doesn't have the same in terms of capabilities, doesn't have supports the same number of services that you get on things like the Azure public cloud, but it's a similar endpoint. So in other words, some of the attacks that we're talking about or that we'll be mentioning can also apply to Azure Stack in some cases. So anyways, let's move and look at things from an operational perspective. So when we look at Azure from an operational perspective, at the top of the Azure organization structure, we have something called an Azure AD tenant, right? So the tenant is what contains the identities that we grant access to. So we have our users, our groups, our service principals, which are essentially application identities, or managed identities, which are essentially resource identities. So we have all these different object types in the Azure AD tenant at the top of the organization structure of Azure, right? Then if we look further down, we can have a management group. So in Azure at the top of that is something called the root management group. So this is something that's not enabled by default. It's something that if you're a new organization to Azure, you need to enable to start using it. But what root management group provides to us is it allows us to be able to simplify management and governance for our organization, right? So instead of managing subscriptions individually, we can manage them as a group. But under the root management group, we have a child management groups, which allows us again to group subscriptions together so we can manage them in an easy way. Then we have our actual subscriptions, which are where our resources that we are deploying in Azure are deployed into. They are deployed into the Azure subscription. Under the subscription, we have our resource groups, which are logical containers that we can use to group Azure resources together so we can manage them together. So if you have resources that share a similar life cycle in your Azure environment, you can group them together under the resource group. And then you have the actual resources, which are the instance of the services that we're actually deploying and running in Azure. So this is sort of like what the Azure organization structure looks like. And the reason why I like to show this is it also highlights some very key points whenever we talk about security. So for example, we can assign permissions to the Azure AD tenant, right? So we do that using something called the Azure AD roles, and we can give permissions here. So if an identity that has permission to Azure AD is compromised, for example, what an attacker can do is they can probably create a new user, modify the password for the user, maybe so this was part of like the recent SolarWinds story where in environments that were compromised, attackers that getting permission to identities that have permission to add secret keys or certificates to service principals, they were taking advantage of that to essentially just create backdoors to the environment. So example roles that you see in this case are things like global administrator, user administrator. So, but that gives permission only to the tenant itself, right? So, but then to give access to the resources that we're actually deploying in Azure, so we use something called the Azure Role-Based Access Control roles. So that's how we grant permission to resources in Azure. And the thing is, we can grant those permission at any of this level. We can grant that permission at the root management group level, at the child management group level. And as you can imagine, the scope becomes very important. And this is one of the common mistakes that I see, like in my engagement with different Azure customers, is people assigning permission at a scope that's too broad, right? This is something that's been hold for a very long time, right? It's been happening since the days of on-premises, but it still happens in Azure, right? Where people give an application or maybe their DevOps pipeline permissions at the root management group level. And then if they were ever to be compromised, an attacker can use that credential to move laterally across different subscriptions that you have in your organization, because again, you've given the permission at a broader scope. So example roles that you see in this place would be things like the owner, the contributor, and the reader roles. But there are many other roles that exist. So you can also create your own custom roles for Azure AD or for Azure resources. Anyways, in terms of what the permission definition looks like, you see something like this. So the permission definition, you see actions and data actions. And what this is referring to is that whatever permission that's defined under the action area, that defines what the user, what the identity can do at the control plane level, right? So at the management level. So you can create a new resource, you can modify the configuration of an existing resource and all of those kind of things. So that defines the permissions that you can do on the control plane of Azure. But whatever permission is defined in the data action section, that defines the permission that you can do within a resource. So an example of that is if I want to give a user permission to be able to modify configuration of an Azure web app, right? I can add that permission to the action level, or let's say like a SQL database or an Azure storage account, I can add that permission on the action level. But if I want them to have permission inside the resource, permission to data inside the blob storage, permission to data inside the SQL database, then that will typically be defined in the data action area of the permission structure that we define over here. There's also something that we can use. So the reason why I bring this up, let's go back a bit. So the reason why I bring this up is it's typical when an attacker gets to an Azure environment, the first thing that you're doing is you're trying to understand, who am I, the identity that's just been compromised? What is that identity? What does he have permission to? And then what an attacker can typically begin to do is to say, what permission does this user have on the control plane level and on the data plane level? Because then that can define the chain of attack that the adversary can put together to say, okay, you've got permission to be able to list the keys of the storage account. So that's good enough. I can use that to get the keys of all the storage account and then use that to compromise your data, right? Or if you actually have permission to be able to read data directly, they can just leverage that and read data directly. There's something that we can use to if we've given too much broad permission at the stages, there's something that we can use to sort of limit that. So that's we can define those in the not action level. So this is essentially saying we're excluding certain permission. We're saying to the user, yeah, you have permission to do these 10 things. However, I'm excluding this one permission from you. So this is very important, especially when we talk about some sensitive permissions that you probably want to restrict within your environment. An example of them is permission to be able to list things like the keys for like your Cosmos DB database, right? Permission to be able to add a new modify the permission structure, right? So that can be used to open backdoors. So one can add those under not actions to ensure that they are excluded from certain users. So that just gives you a quick overview, hopefully, of what the Azure organization structure looks like. And when an attacker views your environment, an attacker views the environment as a graph. So I like somebody else said that, which I like very much. The person said, administrators or engineers look at Azure environment as a list. All they're seeing is list and resources. When an attacker is looking at that, an attacker is looking at that in terms of graph. How are things connected to one another, right? That's something that not very many people think about that, but that's the connectivity that the attacker is looking for in terms of how they can take advantage of certain things. So in terms of the actual services that we have in Azure, as you can imagine, there are a massive amount of services. The last time I checked, I believe there was about 170 services that exist in Azure at the moment. So what I've done here is to break down the different categories of services, right? So the services that we have in Azure. So we have services that we can use to host our applications, right? So these services provide like runtime environment. So that would be like our Azure App Service, our Azure Function, our VM skill set, virtual machines. The services have runtime environments that we can use to execute code, right? But there are also services that we can use to store data for our application. So whether that's structured or unstructured data or semi-structured data. So things like our storage account, our SQL databases, our Cosmos DB and other stuff. Services that we can use to create applications also exist. So services like Logic Apps will fall into that category, where you can actually use it to define a workflow or something like Azure Automation Account. Services that we can use to enhance our application. So the services are not actually providing like any runtime, but they're providing capabilities that can add functions to our application. So services like cognitive services falls into that, right? Just machine learning as a service. Services that we can use to integrate our applications, right? So these are services that, again, they're not necessarily they're connecting application components together. So services like Service Bus, Event Orbit, Event Grid falls into that category. We can use them to connect applications together or integrate applications together. API management can also fall into that category. And services that we can use to monitor or manage our application. So this is just a broad generalization of the different service categories that we have in Azure. And again, when an attacker is looking at these, this ties in with those vulnerabilities that we're talking about, right? So if I'm looking at a service that's used to host an application and that's been discovered, okay, so let's begin to look for application vulnerabilities that may exist in terms of the codes that you're hosting on that. Right? If you're talking about the service that you're using to store your data, let's begin to look for misconfigurations and on other stuff. So talking about that, let's go have a look at vulnerabilities, because we're talking about how vulnerable is our Azure environment. And let's have a look at what vulnerability is. So vulnerability defines a weakness in a system that can be exploited by an attacker to deliver a successful attack. So in other words, there's been a mistake somewhere that an attacker has seen, and an attacker knows I can exploit these to be able to deliver a successful attack. And by the way, when we say successful attack, that can mean many things, right? Successful attack is not just one thing. It's not just about compromising your data, right? That's not everything that it's all about. It's not just about compromising your data or stealing user information. Successful attack can be, I can spin up compute in your Azure environment and run compute at your expense, right? So that's a successful attack, right? A successful attack can mean multiple things when we talk about that. So I'll show you like some charts. I won't get into too much details, but I'll show those sort of matrices to you to see the sort of objectives that when an attacker looks at an Azure environment, these are the objectives that they're looking to achieve. So, but vulnerabilities have different sources, right? So vulnerabilities can occur through software flaws, right? So when we talk about software flaws, so this is essentially unintended functionality. And this is typically due to like poor design or coding mistakes, or maybe just coding oversight that's made when implementing certain applications. So, and in this case, you probably see some at 0 days, which means essentially they have recently discovered software flaws. They are not yet publicly known, so an attacker can use that that because it's not been publicly known and publicly reported. An attacker could try to leverage that. Because not many people will have patched the systems, right? Because they don't even know about it. They don't even know that vulnerability exists. Or they could be publicly reported vulnerabilities that you find in a lot of CVE databases with CVE IDs that exist out there, right? So that could be like the source of like the different vulnerabilities. There could be a feature misuse, right? So when we talk about vulnerabilities, it's not just about like software flaws and CVE IDs. It could actually be a legitimate feature, right, which is intended functionality, but then an attacker has found a way to use that intended functionality in a malicious way. So a very good example of this is for those that are familiar with cybersecurity history, right? There's like this worm that was popular around 1999 called the Melissa worm. Right, so because when Microsoft introduced macros into the Office applications, right, macros were introduced to add capabilities to the Office application suite. Right, it was to allow users to be able to automate the tasks that they are doing frequently. But yet, attackers found a way to use that feature and that functionality in a way to so in the case of the Melissa worm, an attacker used a macro that's delivered through a Word file to take over a victim's Outlook application, send emails that are also infected to the top 50 users on their contact list, and then spread it around that way, right? So when the other user opens it, takes advantage of the macro, again, infects them, their account, takes over like their Outlook, sends emails, and on and on. So that's an intended functionality that was turned around and used in an unintended way, right? And in a bad way. And you see this also with Azure, right, these days. So this happens a lot with Azure. So one of the trends that we're actually seeing in the security community is where attackers are trying to hide behind legitimate DNS of the Azure platform to launch attack from there. So in other words, they are taking advantage of the Azure platform reputation, right? And they're going, but this is not just Azure, this like for all the public cloud provider. They're going, launching, delivering payload, for example, from Azure Blob Storage, right? Because that's Windows.net domain name versus just delivering it from another domain name that has a bad reputation that could be easily blocked by security systems, right? So those are the sort of things that you see that's still going on. Okay. So then we have user error or misconfiguration. So these are cases where there are no software flaws or even features that have been misused, but users have just configured things in a bad way, right? So, weak passwords, that's not a feature misuse, that's not a software flaw, or leaving things at the default password, or making things anonymous, configuring anonymous access, those kind of things, right? That's user error, that's misconfiguration. And those are the different sort of like sources of flaws vulnerabilities that you see. So let's bring that back home. So let me look at the time here because I want to get to the demo, which you'll probably find more interesting. So, okay, yeah. So this is the core of what I'm about to discuss today. So let's pay attention to this. So because when we talk about Azure and we talked about the different categories of services that we have for hosting applications, running applications, integrating applications, storing data for applications, and all these different services that we have for Azure, right? What this platform is about, if you look at the core of it, is to allow organizations to be able to deliver cloud native applications. And that's the core of it. So you have this amazing platform with lots of services you can use to deliver cloud native application. You can use to enhance your application and deliver these intelligent applications. But one thing that we know about cloud native applications is that they are highly distributed and they are also very complex. So when we're talking about cloud native, we're talking about multiple tech stacks, right? We're talking about all kinds of programming languages that are out there and different types of libraries. We're talking about applications that are implemented as microservices. So now you have multiple components. They are interacting with each other using APIs. They are interacting with external services using API. They are spread across different environments. So that's very complex when we talk about from a security perspective. That can be complex thing to do. But let me give you a model. When you're thinking about Azure security in the context of cloud native security, here's what we're actually talking about. So this will hopefully simplify it for you. So what we are typically talking about is we have our code. And our code can be written in any type of language that's out there, right? We have our code, and the code is typically running inside a container. And I say typically because it's not always the case. We still have multiple monolithic applications out there, or even microservices applications that are running directly as compiled code on host, and they're not running inside a container. But typically these days you have your code running in a container. The container is running inside a node or inside a cluster of nodes. And the node or the cluster of nodes is managed by an orchestrator or by an Azure Platform service. So services like Azure Web App, Azure Container Instance, Azure Functions allows us to run containers natively directly on them without having an orchestrator, right? And all of this is hosted on a cloud platform, right? So this is what we're talking about. And this is what makes cloud native security a bit complex from a practical standpoint, right? Because what you're looking at is these different components, and these different components operate on different security models, right? So, and then, so for example, the model that you're looking to secure your code, right? It's different from the security model that you're going to be using to secure your container. It's different from when you're looking at operating system or node security. It's different from the orchestrator or Kubernetes or OpenShift security model or the platform service security model. And that's different from the cloud service or the cloud platform security model. So we're talking about all these different security models that one needs to look at. And it's very important that when we think about Azure security, we should not think about things in isolation, right? This is what I call the intersection of risks. Any risk that's introduced at any of these levels or layers has an impact on all the other levels or layers. And I'll show you an example of that in a demo today of how something gets compromised at this level can be used if misconfiguration is made at another level to essentially move around and start beginning to exploit other services over here and vice versa. So those are the things that we need to watch out for. But bringing this home again, so when we talk about things like the platform, we're talking about issues like platform misconfigurations, overprivileged access of Azure AD identities. We're talking about platform bugs, which really happens with Azure. Microsoft are great with what they've done with security. In my own opinion, I think Azure is one of the top cloud providers that take security seriously. So from what I've seen, Microsoft does an amazing job in terms of taking the security of the platform very, very seriously. So then we have from our service perspective, which are the services that we're creating in Azure, right? We can have issues like we're misconfiguring the services themselves. So an example of this would be somebody putting a secret key or an API key, right? Or a database connection string and adding that as an environment variable to Azure Web App, right? So those are the kind of issues that you get on this level. So this is different from you assigning permission on a management group level and stuff like that you get over there. So on the orchestrator level, we're talking about issues like orchestrator misconfigurations. Kubernetes is amazing, but it's very easy to misconfigure it, right? So there's a lot of misconfiguration that happens. We're not even going to get into that today. So you can have weak credentials. You can have robust access control gaps where you've, again, misassigned permission where people, if they exploit a workload, can take advantage of that to exploit other workloads, which normally they should not be able to. You still have your OS and your kernel issues that exist over there with your kernel bugs, with your file permission errors, with the OS misconfigurations that people are doing, with third-party libraries that you've deployed and the vulnerabilities that exist on them, right? So your container runtime can also have issues. So Azure Kubernetes Service defaults to containerd now rather than Docker. So you can have your secret exposed incorrectly within your containers. You can have root privileges where they're running as root on the nodes. You can have vulnerable images that actually have backdoors built into them. You can have insecure networking where the networking is loose, that if a workload is compromised, that can be easily moved around to another workload. Then you still have your normal application security issues like your SQL injections and your CSRF and SSRF and remote code execution and all the different types of vulnerabilities that you still have at the application level, right? So those are the sort of things that we need to consider, all of these different things when we're talking about Azure security. Okay, so looking at time, I'll get to the demo now, but just quickly show you without going into details, sort of like what an attacker is looking to achieve in an environment and some of the different ways that they can take advantage of any of this. That could be software flaw, so that could be misconfiguration, but anyway, they can take advantage of any of these to try to achieve their objectives within your environment. So if an attacker has an objective of discovering like your Azure resources, and that's what they're looking to do, there are multiple ways that they can use in order to discover your Azure resources that you have in Azure. So, and we won't get into all of this, but I just want to show you in terms of the range that we're talking about here. And some of these are based on the MITRE ATT&CK framework. Some of these are based on my own personal research in terms of looking at how attackers can take advantage of legitimate Azure features and to essentially cause damage in an environment. So if an attacker is looking to access credentials for Azure environment, there are multiple ways you can credential guessing, compromising a resource that has managed identity, stealing the token from there, looking at your application credentials, your environment variables, and getting your applications from there, looking at log files. If you're looking to get initial access, they can target the host that you're using to run your application in Azure. So there are multiple ways. If they're looking to execute code, there are different approaches that an attacker can take. So when you look at this, I want you to think of this as the different approaches that an attacker can take to exploit vulnerabilities in your Azure environment. So this is what this is showing to us. And without going into too much details, I want to show you, like, just so you know, when we talk about the complexity, what we're talking about. So that is like the Azure platform. Now, if you now take that to like the containerization, actually like just looking at your container workloads, looking at Docker, Containerd, and Kubernetes that your workload that you're running, that's a whole different list by itself. So you can see why this can be really complex, because now you have to deal with not only the platform layer, now you have to deal with all of this and look at all the different ways that an attacker can take advantage of this and see how you can either stop that misconfiguration or mitigate that software flaw, or make sure that you have like proper microsegmentation in place to ensure that a feature cannot be exploited. So anyways, I'll stop now because I want to get to the demo, so I'll just discard that. Let me go very quickly. So the demo that I'll be showing you today, it's on this, and I'll give you a bit of information on that. So I'll give you a demo. I'll show you a demo on exploiting ACI. So for those that are not familiar, I'll talk about ACI briefly in a minute. So ACI stands for Azure Container Instance. Microsoft describes it as the easiest service to use to run container images in Azure. So here's an example of what I'll be showing you. So we have like a web admin application that's running, that's public. It's exposed on port 500, and that's the DNS name. It's got a public IP address. So just a normal web admin service. So an attacker scanning that, and essentially at this stage detecting a remote code execution vulnerability that exists on that. But what the attacker is now doing in this case is detecting the remote code execution is to open a listener on the attacker system, send a brief piece of code to get it to open a reverse shell to the attacker's environment, and then the attacker can essentially begin to just gain access to that command line of and the environment, the ACI environment. And once the attacker gets that, you can see the intersectionality here, because the method to get in was an application vulnerability. The method could equally have been a cloud configuration vulnerability. It could be either, right? But they all intersect with each other. So anyways, the attacker begins to look around in terms of like was hosted on that and found like a MongoDB database, which this is talking to on port 27017. So that's private, so that's not public, but the attacker now on the system is able to begin to exploit that. So looking around again, the attacker finding that, okay, this container instance actually has a managed identity assigned to it, and the attacker essentially making a call to Azure AD and obtaining the token for that managed identity, and then begin to now use that to interact with the cloud environment. So in this case, the attacker begins to enumerate the environment and see what services exist. They're looking at what permission that this access credential has, or this access token has, to be able to do on Azure Resource Manager, and then taking advantage of that. Right. So this is sort of like the scenario that I'll show to you very quickly. So let me go over to just show that to you right now. So what I have here is, let's go. I have, let's bring up this environment over here. Here we go. So if I go over here, hopefully that all responds quickly. So what I'll do over here is I'll just go over to that resource group. You can see that I have this container instances that are running, and they're both running the same applications, but I'll show that to you. So if I go to this first one, right? So that's the URL endpoint is listing on port. It's listing on port 5000. So from an attacker perspective, let me get the system up here. So from an attacker perspective, what I can do is I'll copy that URL of that application, and I'll just put that in a quick variable over here. So let's go ahead and do that. So go ahead and say URL equals to the URL that we're looking to exploit, and we got that in the variable now. So what I'll do is, just to make this much more easier, I'll also just save the session, because it's a web admin. It has a basic authentication. So let's say the attacker has been able to compromise the basic identity of that. So let's go to, oh, what did I do wrong? Come on. Okay, do I have this running? Yep, it is running. So, oh, okay. Gods of demo, come on. Let's get this up moving. Okay, 1 minute. Let me just quickly have a look and see. Oh, okay, I think I can see why. You know what? My bad. Look at me, naughty David. What I've done is I've not added the right port. So it's probably trying port 80 and it's failing. So let's do that. Let's run that again. And that's better now. So I've got like my eCloud admin console that's running in this environment, and logged in with just basic authentication, right, to the environment. So scanning that, discovering like a remote code execution vulnerability that exists on the application plane now, right, and then begin to exploit that. So what I'll just do is I'll just run simple command to say just run a list, and I'm able to do a list on that, right? To see that, okay, I'm able to execute code on this instance. At this point, I have no idea what service that's hosted on, where that's hosted and all that stuff. So at the point, it's just interacting with things strictly at the application level and things like that. So now we can begin to poke around a little bit into that to see what can we jump out. So in this case, what I ran was I ran the command to get the environment variable, and this is a typical way the attackers use to see what environment a service is running in, right? So in this case, I can see some very interesting information here. So the first one I want to call out to you is this information on, if I scroll up, so let's see. So we have Python, we have Kubernetes service, hostname, blah, 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 blah. And oh, am I in the right one? Yeah, I'm in the right application. Okay. So let's see. So I can see the Python version that's running, right? So, but still, this doesn't give me like the full type of information that I'm looking. I can see things like the host name, and I can just see just basic information about the environment. It's a Python application, and some references to Kubernetes over here. But again, I know we can execute code on that. So let's begin to take that a bit further. So 1 minute very quickly, just make sure that I have the right things enabled. Yeah, that's fine. So let's go back. So what I'll do here is I'll take that further and I'll look to open a shell on that. So to do that, what I'll do very quickly is I'll open up my attacker system to listen on port 4444, and I'll drag that a bit down, and then I'll go run a piece of code to get the environment to essentially make an outbound call to my attacker system to open a reverse shell. So that's what I'll be doing in this case. So let's get this and let's get that, and I'll just go ahead and run that. And if I run that, and there you go. So just running that, it's made an outbound call, and now I have shell access to that container instance, and then we can begin to poke around on it even a bit more, right? So I can begin to look at that in much more details and see what exactly is running, what's going on in that environment. So anyways, let's move further in this one. So now that we have access to the cloud environment, we can probably begin to look around and see what exactly is going on. If I do a net start-a, I can see that net start is not installed, right? And I can see that I don't have that much access to many things. So what I'm going to do is I'm going to look to just install certain capabilities on this to look to enhance what I can do. So we'll just give me 1 minute here. I'll grab my offensive one, and I'll just go ahead and run some commands to install some tools on that system. So apologies. Let's go to, okay, yeah. So I'll just run some quick tools on that. So run some tools over there. Right. And again, remember that because this is an Azure container instance, the underlying operating system is something that a customer does not manage or have access to, where they can install anything on it. It's just a service that you can use to run container applications, and that's it. But again, you put a vulnerable application on that, or you put an application that's vulnerable, and then you've given it too much broad permission, you can get into serious trouble where there can be essentially leverage to compromise a whole subscription from that perspective. So once it's finished unpacking the Azure CLI that I'm installing, then we can go further in the attack chain. So let's go, come on. It will take a long time, it will finish shortly. So while it's doing that, I'll just quickly, okay, yeah, you know what? It's as if it was hearing me. So what I'll do is, so once that's finished, I can begin to check other things. So what I'll do here is I'll begin to do, because I've installed net tools now. So if I do my net start, let's spell that correctly. Right, I can see different information. By one of the important things I can see is I can see that that's the port that it's listening to, but I can also see that it's listening to port 27017. So in terms of Azure container instances, there's the concept called container groups, which allows us to run multiple container images on the same host in the same environments. They share the same volume and system process and all that stuff. So I can see that just port 2707. I know that that's the port that MongoDB is using. So want to begin to interact with the MongoDB that may be hosted on another container, which is what's going on in this case. MongoDB is hosted on another container that's using. So I'll just go ahead and install the MongoDB client, and then I can begin to interact with that. So if I go Mongo, and if I do a show databases, I can begin to see that, okay, it's got like these different databases. I can begin to switch around to the database, show the collections that exist in that. right? Show the collections that exist in that, and I can see certain information. So again, we can begin to move around in the collections and begin to, so if I do db.restaurants.count, so see how many items, so that has about 25,000 items. Then we can begin to dump that information out, right? And begin to restaurants.find, right? You can begin to dump that information out, see if we have like any PII that can be leveraged in other attacks that an attacker may be looking to perform. So, but that's just essentially moving and compromising, using from an application vulnerability, compromising another workload that's running in the same environment from there. But then we can now even take that further, and then we can begin to see. So what I'll begin to do here is if I go back to quit, right? And if I do my environment variable, right? And so there's a particular environment variable that I'm looking for. So this may be like a recent change that's just been made to this service where the environment variable no longer is populated for security reasons. So if Microsoft has done that, so kudos to Microsoft to obscure that now. But essentially, like in the past, there used to be an environment variable that will be populated if you have a managed identity associated with a service like Azure Container Instance, and you'll be able to spot that environment variable here. So, but that seems to be hidden now. So, but in this case, you know, let's say an attacker finds that it has an environment variable, or maybe an attacker does not know and just wants to try and see if that works, whether the system has an identity. So an attacker can essentially go az login identity, let's get that right, and see what happens with that. And that's successful, so which shows that this environment that this is running in actually has a managed identity associated with it. So now what an attacker can begin to do is to begin to see. So number one thing an attacker can begin to do, just to show you that, is an attacker can, for example, export all of these, because those are the cached access tokens, and export all of that and begin to use that from an external environment, right? Or even using this container as sort of like the landing place, an attacker can begin to check around to see, okay, what permission does this resource actually have to the Azure environment? So in this case, running that simple line shows me it's got access to one subscription, it is using a service managed identity, right? So, and then we can begin to dig down into that to say what exactly what permission does it have in the environment. So I can begin to pull that up, and what we see here is that's the ID of that. So I can get the ID. I'll just put it very quickly in a notepad that I have over here. Let's go get it in notepad. So actually, you know what? I'll just go ahead and just put it in a variable. That'll be easier for me. Yep. So once I have that in a variable, I can then get the information and say, show me what permission that does it have. And I can see that it has reader permissions. Now you may be thinking, what can you do with the reader permission? So it has reader permission to that subscription, right? So the scope is the subscription level, and it has reader permission to that. So you can do a lot with reader permissions, right? That's for another topic because with the reader permission, you can do a lot of damage. You can escalate your privileges in a lot of ways. All you need to do is study the matrix that I showed earlier, and you'll be able to see that. So an attacker can begin to take this further. So for example, we can even begin to export tokens that we can use from an external environment. So I'll give you an example. So I'll obtain a token for the Azure Resource Manager. So that's the Azure Management Plane, because this identity has reader permission, obtain a token for that. So if I do echo token, if I can get my echo typed correctly, echo token, and you can see the token here. I can grab that token, and I can open up a new environment over here. So if you think about this from now, an attacker now going externally now and then taking that token that they've just obtained, and then can go token equals to the token that we just obtained. And with that token, then we can begin to make calls to the Azure environment. So for example, I can now, so this is from an external environment now, not from the container instance. Now I'm making a call using that. I'm talking to identifying myself to the management plane and saying, show me all the subscriptions that this has access to. And I can begin to see that information, and then you can begin to proceed further in the attack chain. So in the interest of time, I'll stop there. There's a lot of other things that I wanted to show you how an attacker can use this to sort of begin to read information in container images and begin to hunt for credentials, but we don't have sufficient time to show you. So anyways, let me bring this to a close now for questions that we may have. So also, like, one of the things that I wanted to quickly point out is how people could, for example, have defended against something like this, because that's also important. So something like this could easily be defended against if people have things like runtime protection, regardless of the environment that they're in. So that's very important. Even when you're using managed services in Azure, like app service, it's important when you're hosting your application in a containerized form to still have that runtime protection. That's critical. It can save you from this kind of issues, because it's it's impractical to assume that, oh, this will never happen. This can happen, right? And it's also impractical to think that there will never be a zero-day vulnerability to an application that you're hosting in an Azure Container Instance or Azure Function. There will be a zero-day vulnerability. So you always want to have that added layer of defense. So what I'll do very quickly is I'll just show you an example of, if I go to manage, if I go to defend runtime, so I'll just configure runtime protection. So if I go to app embedded policy, and I'll just add a quick runtime protection to say I've got an application, say web admin runtime protect, and I can run web admin runtime protect. And in this case, I'll just leave it set to alert, right? I'll just leave it set to alert. I'll set the names of allowed processes. So things like, so I know it's a Python app. So Python, let's say app.py, which is the entry point. So I had all of those, and I go to save that. So I have this runtime protection rule that I've configured in this case. But now if I go back and I'll cancel a bunch of this, right? So what I'll do is I'll do the exploit again. In this case, I have another app that I'm going to be exploiting, which is running the exact same thing. So if I go ahead and run that, if I go to monitor events, and I say, show me any events that's going on for my app embedded, where you, app embedded audit, and list that, right? And if I go back over to this environment over here, and if I go to my URL, let's just modify my URL very quickly. Oh, no. Okay, here we go. So 5,000, and that is 199, right? So I've got that configured. And once I have that configured, what I can do is I can go to perform to specify that. So I'm able to connect and use my application. But then if I begin to do other things like try to install things on that. So for example, I ran that ran successfully, but that has alerted me to say, hey, there's something that's running a process that's not part of your allowed process, right? If I begin to proceed with that, and I can begin to run that and do things like, it's like, okay, yeah, that's somebody running something, a process that's not in your allowed list. So then I can begin to improve my protection capabilities to say, defend runtime, and begin to say, don't just alert me on that, also prevent it, and also monitor for anything that does not belong in the original image that's trying to run. And if I go ahead and save that, and if I go back to my environment over here, and if I go ahead and try to run this again, so let's go back. Right, if I go ahead and try to run that again, you see that that's not successful anymore, because now that's been prevented. It's like you're not allowed to run the things that you're trying to run. So anyways, that brings me to the end of this. So apologies for pushing it a bit later than I expect. But one of the things that I want to leave you away with this is your Azure environment is as vulnerable as your weakest security model. So pay attention to this again. Those security models, any vulnerability, software flaw, misconfiguration at any of these impact on other. It's an intersection of risk. That's my term that I use for it. They are all connected to one another, and you need to look after all of them. In terms of the key areas that you need to focus on, assessing the configuration of your platform from an identity perspective and from just a resource perspective. In terms of the entitlement of the scope that you've assigned permissions, that's very important, not to assign broad scope of permissions. Application vulnerability assessment is still important. Application security is the application security that can be the entry point. At the same time, you have to ensure that runtime protection is also important. So do not do away with runtime protection because you're using microservices, right? So let that be like sort of like your last stopgap. So that brings me to the end of this. I hope that you've learned a thing or two. If you're looking to follow me on social media, follow me. I do a bunch of content on Azure offensive security. So that's the area I do a lot of research in. But for now, I'll hand back over to you, Mike. Thanks very much.
Well, thank you, David. That was very, very interesting. And I hope that our viewers enjoyed your session too. I mean, for me, it's a very nice way of showing how weak your system can be based upon every piece of component that you're using. I always preach it the same way. Your security is only as strong as your weakest link. It's like an onion, right?
Yeah.
You start at cord. So yeah, there's a lot for it to say. So I got a question for
Yes.
you. Are you a strong believer in? You showed us a couple of techniques and you showed us a couple of things that could go wrong.
Yes.
Where do you think you should focus on when you're talking about security from a cloud aspect? Should you focus more on a shift left motion, or should you focus more on the endpoint protection, or everything in between? Because if you take a look at Azure, Azure is a broad scope.
Yes.
I mean, we have mechanisms that are put in there to help you a little bit.
Yeah.
But what is your opinion on security where it should be pushed?
Yeah. Carry on, sorry.
No, go ahead.
I think that the approach of shifting things as left as possible is the right approach, because that's the only way that's practical, right? If you look at the scope of what we're talking about over 170 services in Azure. Now, if you look at all the different configuration components that people can add to those services, right? And for 170 services, and you now add that to 100 subscriptions. It's not practical to go, oh, you've got to know the best practices for all of them before you start building stuff. You know, I've got deadline to build my project. I have no time to go study all the best practices for that. It's got to be shifted left. It's got to be automated. It's got to be part of the normal process. So that is definitely the right approach to use. However, that does not take away those endpoints. Like what you saw, like all that needs to happen is, even though you're doing all of those assessments, all that needs to happen is 1 0 day. Like a lot of it. So it's very important. If you look at like what happened with the SolarWinds attack, the organizations, the organizations that were looking beyond just stuff, that were actually looking at the behavior of what is this thing actually has to do with my environment, were the organizations that were able to prevent those. Right? They were able to go, okay, I trust SolarWinds, or I trust SolarWinds, but then I'm seeing this strange behavior that should not be happening, and then I'm stopping that. So that is obviously still important, right? Especially for the 0 days that we're gonna get, but they're not gonna go away.
That was a very nasty one, the SolarGate one. I mean, the world has been shocked by it, and that actually proved a little bit my point. The funny thing is I also preach some security from a DevOps perspective, so how you can secure that total environment, and I totally preach a shift left focus. That's something we should all focus on. But yeah, indeed they got the bad practice that somebody got access to source code apparently for some reason, and things happened there. So that's a 0 day, but an intentional 0 day put in there. So unfortunately that happened. You demonstrated something, the prismacloud.io.
Oh, okay. So that's a Palo Alto solution. Yeah. But essentially, like what I was trying to drive home is, when it comes to cloud native application, because I've seen people go, they're microservices anyway, just kill them and start them again. But if you tie that in with security statistics and security metrics, right? And you look at if an attacker gets access to an environment, the dwelling time before they're actually discovered, right? That's a lot of damage that could be done. Months. Exactly, yeah. So that's a lot of damage that could be done. So going with the approach of I can just kill it, that's not the best approach from a security perspective.
No.
Because what you also want to do is you always want to have that stopgap to say this container application is meant to be behaving this way, and it should not deviate from that behavior. Even though I'm doing all my vulnerability checks on the pipeline, I'm doing all my continuous assessment and continuous validation. At the same time, I want to ensure that when it gets to production, it's only doing what it's been set to do in the pipeline, right?
Exactly. Yeah. You need to check that lateral movement. As you said, there's 3 to 6 months before an attack actually get noticed. They do a lot of reconnaissance before that. There's nasty things going on there, but that's pretty cool. So that Preserved Cloud, that was one of your tools for the company that you work for, because you work for Palo Alto. But I think it's a seam, right? It's a seam sword kind of. It's more a seam than a sword, I think.
Okay. So if you're familiar with like Twistlock, what Twistlock does, so that essentially that's a Twistlock solution. So it's like really? Okay. So that's the Twistlock solution. So it's like cloud native application protection, where it actually providing that protection from vulnerability assessment of your images in the registry, in the pipeline, and all of that stuff. Providing the compliance assessment of the host environment. So those are the different intersections that we're talking about. Providing as configuration assessment from like the cloud perspective, but also having those stopgap of runtime protection in place for the host, for the container, even if you're using an environment. That to me is very important, because if you're using an environment that's managed, where you can't actually go install something, right? If you're using like Azure Container Instance, you can actually go install something on that. But these are amazing services that allows your organization to be productive, right? So these are amazing services that you want to use. Just ensure that you have those stop gaps in place, right? It's sort of like the message here is the services are amazing. Make sure that you consider all this intersection and make sure that you have certain stop gaps in place.
Okay, exactly. Yep, that's indeed a good practice. I wonder if there's any more questions coming in from the audience. Let me quickly check. If you have any more questions, now is your time to ask them. And if not, you should be silent for the rest of your days. No, until the next session, of course. No, it doesn't seem that there's too many. A lot of people found the presentation interesting, so that's a good thing. You already scored some good points. All right.
Thanks.
So since there are no more questions, I think we are. There you have it, Michael Bidix. Thank you for your comment. I think we are at the end of the show then, and I think we've all enjoyed it. I hope you enjoyed being with us. Unfortunately, not in real life. Let's hope one day we can make this happen.
Yeah, hopefully. I love it. And thanks very much again, Mike, for the invite. Really appreciate it. Really enjoy the time. Again, always enjoy talking about security.
It's our pleasure. It's our pleasure. And on that bombshell, viewers, I would like to wish you a very pleasant evening and already looking forward to the weekend.